In this video, I will be going over checkpoint 12. Here's our first question. So the first question wants you to match each probability event with the event that also has the same probability. So what we're going to do on this one is I'm going to go through and help you figure out the probability of the three knowns, and then you're going to go through the different options and figure out which ones have that same probability, okay? So you're going to know one, and then you're just going to have to figure out the other. I don't think I like the way that looks. Let me just do it this way. All right. So the first one is rolling a 4 on a 6-sided dice, okay? Well, if we think about it, right, a dice has 6 total sides. So 6 is my total here. And out of those 6 sides, only one of them is a 4. So this first one has a 1 out of 6 chance of happening. The second one says rolling a number that is less than 3 on a 6-sided dice. So think about all the numbers I have. 1, 2, 3, 4, 5, 6. 1 and 2 are less than 3, right? 3 isn't less than 3 because 3 is equal to 3. So I have 2 different options out of these 6 total ones, right? Because I could roll 6 different numbers, but 2 of those options are less than 3. And then this can also simplify to 1/3. So 2 over 6 or 1 over 3. All right, the last one says rolling an odd number on a 6-sided dice. Well, again, think about our numbers. 1, 3, and 5. These are all odd numbers, right? So those are 3 different numbers I could roll out of those 6 total that I have. So I could roll 3 out of 6 or a 1/2. So I have a 50-50 chance of rolling an odd number when I roll a dice. So those are the known probabilities for rolling a 4, rolling a number less than 3, and rolling an odd number. Your job now is to go through the drop-down list that you'll get when it says select an option and figure out which ones have the same probability. All right, number 2 says that Jaden did an experiment in which he pulled a marble from a bag, recorded the color, put it back, and then repeated. He did this 18 times. 6 of those times he pulled a yellow marble. Which bags of marbles are good models for this experiment? All right. So for this question here, it says that 6 out of those 18 times he pulled a yellow marble, okay? So this could simplify to 1 over 3. If you type it into Desmos, 6 over 18, and then hit the fraction button over on the side, it'll simplify it for you, and it'll show you that it's 1/3. So what our job to do here is to go through and figure out the probability of pulling a yellow for each one of these. Okay, so that means I'm putting the number of yellow marbles over the total number of marbles. Okay, for this first one here, there are 2 yellow, so 2 is going to go up top, over my total, which is 4 plus 5 plus 2. So 4 plus 5 is 9. 9 plus 2 is 11. This next one here. So I have 4 yellow marbles over total. So 6 plus 2, which is 8. 8 plus 4, which is 12. Next one says I have 5 yellow marbles over my total. So I have 4 plus 6, which is 10. 10 plus 5, which is 15. Next one, I have 9 yellow marbles over 15 total. 9 plus 6. And this bottom one, I have 6 yellow marbles over 24 total. 6 plus 6 plus 6 plus 6. So from here, let's see if we can simplify any of these fractions. And if we can get this 1/3. Well, 4 over 12, I know, reduces to 1/3. 5 over 15 reduces to 1/3. 9 over 15 reduces to 3 over 5. And 6 over 24 reduces to 1/4. Again, you can type these into Desmos if you're not 100% with simplifying your fractions. So say I typed in 4 over 12 into Desmos, all I have to do is hit this fraction button on the side and it will simplify it for me, okay? So if I look, these two right here match my original probability from this problem, which means that these two options are good representations for this experiment because the probability of pulling a yellow marble from either one of these bags is the same that Jaden got when he did his experiment. Next question. The probability of pulling a blue marble from a bag is 0.25. Which of these bags are good marbles? Or are good models, not marbles. They all have marbles. So for this one, we're going to do the exact same thing that we did on the other one. However, I like to work with fractions when I'm doing probability, just because that's what we're used to seeing. So this 0.25, I want to change to a fraction. That's how I'm going to figure out this problem. You can keep the 0.25 if you like. If you don't know what that is as a fraction, type this into Desmos here correctly. That'll help. And then hit this fraction button and it will tell you it is 1/4. Okay, so let's go through and figure out the probability of pulling a blue marble from each of these bags. Remember, that's the number of blue marbles on top over the total. Let's looking at this first one. There are 3 blue marbles. Add up my total. 5 plus 9 plus 3. 5 plus 9 is 14. 14 plus 3 is 17. The second one here, I have 3 blue marbles over my total. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 5 is 11. Plus 1 is 12. And remember, if this is hard for you to keep track of in your head, like this one down here, I see that there's 10 blue, but I know that there's a lot of numbers and I don't want to make a mistake. Type it into Desmos. That's okay. Right? I have 6 yellow, 5 red, 10 blue, 12 green, and 7 purple. There's a lot in this one. So type it into Desmos. And then this bottom one, I have 10 blue over 23 total marbles. I can't simplify that top one. This one, the middle one, I know simplifies to 1/4. The third one simplifies to 1/4, and I can't simplify that bottom one. So the middle two here match the original probability that was given in our problem. So that means that these two would be good bags of marbles to represent this problem. So a lot of repetition here. And remember that using Desmos can make this go a bit quicker. All right. Our next question says, what is the probability of drawing a face card, Jack, Queen, or King, from a standard deck of 52 playing cards? So for this one, you need to know what a standard deck of cards looks like. If you don't know what a standard deck of cards looks like, go to Google and type in deck of cards and go to images. This right here is a great image to look at to reference if you're not sure. You can see that there are the 4 suits. So there's clubs, there's spades, there's hearts, and then there's diamonds. You could see that there are 4 ace cards, right? 1 in each shape. These are all the numbers cards. And then over here are all of the face cards, right? Jack, Queen, and King for each of the 3 different suits. So when you get to questions like this that say, what's the probability of drawing a face card? You need to know how many of those there are. If I were to go here and count, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There are 12 different face cards. And like it tells us right here, there are 52 total cards. There's always going to be 52 cards in a standard deck. So 12 out of those 52 cards are face cards. So probability of drawing a face card is going to be 12 over 52. Number 5. So this is the same type of problem that we've been doing. So I'm going to do this one the same way we've done the other ones. So here we want to, let's see. So Weston did an experiment. He did it 36 times, and 9 out of those 36 he pulled purple. So now we're looking at purple. So 9 out of 36 is the same. It'll reduce to 1/4. So for the first one, I have 1 purple out of 4 total. I have 4 purple marbles out of, let's see, 4 plus 5 is 9, 10, 11, 12. I have 4 purple ones here out of 16. I have 9 purple ones out of 27. So again, I'm putting the number of purple on top and the total number of marbles by adding all of the marbles together. So like 1 plus 1 plus 1 plus 1, 4 plus 5 plus 2 plus 1. That's how I'm getting these denominators. So 1/4, that just stays 1/4. I don't know why I put an equal sign there. 4 over 12, that simplifies to 1/3. 4 over 6 simplifies to 1/4. 9 over 27 simplifies to 1/3. And again, type these into Desmos if you're having difficulty simplifying your fractions. That's okay, like I've shown you 2 times now. So that means that this first one that has all of 1 of each color, and this third one here that has the 4 are the ones we want to pick. So first one and third one, each one that has 4 of each different colors. Next question says that Francina performed an experiment in which she randomly pulled a marble from a bag, recorded its color, put it back, and then repeated. The following table represents the number of times each color marble was pulled. Which bags of marbles best models this experiment? Okay, so again, same process as we have been doing, except just a different question. For this one here, it's a little bit different. And I'm trying to look and see if we don't actually have to do a bunch of math here, and if we can just base it off of the design. Awesome. Yes, we can. So if I look at this table here, purple is pulled the most, right? Which tells me that purple should have the most marbles. Blue is pulled the least, which means blue should have the smallest amount of marbles, and yellow is in the middle. Okay, so when I'm looking through my answer choices here, I'm looking for any choice where purple has the most. So purple has 6 here, but 9 has yellow. So that's a nope, because purple needs to have the most. Here purple is tied, so that could work maybe. Here purple has the most. Here purple does not. So now we're looking at these two, because purple has the most or tied in both of these. Next we're looking for yellow. So yellow needs to have the second most. And if I look, this has 2 yellow and 6 blue. But if I look here, blue should be smaller. Blue should be the smallest, right? Which means that this choice here, where I have 6 purple, 2 blue, 4 yellow, is the one we want to pick, because that goes with how our table goes, right? Purple has the most, purple's the biggest, yellow is the second, yellow's the second, blue is the smallest, blue is the smallest here. All right, next question says that the probability of a spinner landing on a 3 is 0.125, and the probability of landing on an even number is 0.5. Which of these spinners best models this probability? All right, well, right now I want to type in this 0.125 into my Desmos, because I want to know what that is as a fraction if you don't already know it. 0.125, hitting this fraction button, is 1 over 8. This is important because that means that 1 out of those 8 slices in my spinner needs to be a 3, okay? Because it says that landing on a 3 is a 1/8 chance. So if I look at this first spinner, there's not even a 3 on this spinner. So that one's immediately out. On this second one here, there is a 3. However, there's only 5 sections. And remember, the probability of it landing on a 3 is 1 out of 8. And there's not 8 choices here. This next one looks like it could work. There's a 3 here. It's one of the sections, and there's 8 total. So this one looks good. This bottom one here, there's only 1 3, so that will not work. Well, sorry, it's not that there's only 1 3, but that's broken into 3 different sections, and it needs to be broken into 8. Because remember, probability of landing on this 3 is 1 out of 8. So this spinner right here is the spinner that we want to choose. So the 1, 2, 3, 4, 5, 6, 7, 8, that has the 3. All right, next question says that a spinner has equal chances of landing on each of the sections. So orange, purple, and green, perfect. What is the probability of landing on a color other than green? Well, there's 3 total sections, right? 2 of those are not green because it's asking for any color other than green. So we would have 2 out of 3, so 2/3. Our last question says that 12 students are chosen at random from a 7th grade class. 4 of those 12 students named math their favorite subject. Which class survey shows the results that best model this experiment? So again, we're going to be doing what we did before with those bags of marbles, except instead of having bags of marbles, now we have these tables. Okay, I'm going to extend my thing. And really quick, 4 out of 12 students. So 4 out of 12 is another way of saying 1/3. That's what it simplifies to. And this is 4 out of those 12 said math was their favorite. So I'm putting the number of math in my numerator and then the total in the bottom. So again, here I have 6 people who like math. My total is adding up each of those numbers. So 6 plus 6 plus 6. That's going to give me 18. For the next one, I have 12 who like math and add up all the numbers in the table. So 4 plus 12 plus 4, that's going to give me 20. The third one, 4 who like math out of 22. Again, add up all your numbers. And then this very last one, 4 like math out of 16 total. So let's simplify these and see which one gives us this 1/3. 6 out of 18 simplifies to 1/3. Well, that was quick. On this one, we're only picking one table because it's not a select all that apply. I can only choose one. So that means this table that has 6 of each student who likes each of the different subjects, this one here is the correct one. All right, that is it for checkpoint 12. If you have any other questions, please let me know.